All right, for all those wonderful people that decided to show up to class today, thank you very much. So, class. Yeah. Ooh, all right. Anthony, well, what's up? See, Anthony's chilling. All right, so let's go ahead and continue the notes. Mean value theorem. Now, this one right here, go back to a little bit of what the basic of integration means. Integration on a graph, I'm finding the what?
Area under the curve.
Yep, area under the curve. So that's important. So area under the curve says that it's basically width, which is b minus a, times height, which is f of x, or f of u in this case. So this right here, the mean value theorem, says that there is some value right here, the actual area, which is this one right here, is equal to, right here, b minus a, which is going to be the width times the height. But the height is going to be the fu. Because there is some point that this one right here is equal to the average. Yeah. Because yesterday when we were talking about it, we had the minimum, which is the lower, and we have the maximum, which is the upper. In my two estimations, I have an overestimation and an underestimation. So there's somewhere in between where the height here is going to be equal to the actual area. Does that make sense? Kind of? Okay, so I'm going to do a little finagling with this. So if these two are equal, wouldn't that be the same as saying, if I could divide both sides of b minus a, wouldn't that just be 1 over b minus a, integration from a to b of f of x dx is equal to f of u. And f of u implies what is that y value? Because all this means it's the area. And area basically is width times height. The width is my b minus a. My height is going to be my fu. So every time you guys talk about doing math in this class, you guys should always be thinking fu, right? See what I did there? Hey, Joseph. You see what I did? You know, like fu, the function of u. Like the other, like bad word type. Yeah, there we go. So everyone should be very excited about yelling fu at your teacher here, right? Yes. Right, Pancho said so! I can say fu! Okay, anyway. So, that's the equation right there to actually get my f of u. So, it comes out like this. They ended up not rewriting it. But, yeah, it just comes out to 1 over b minus a times my integral is equal to my fu, which is basically this is my width, and this is my height. And then we'll eventually find the x in the fu, too.
Where's the x? What?
You'll see in a second. So, find the numbers u guaranteed by the mean value theorem. Okay, so if I go back to what I said, it was 1 over b minus a integration from a to b of f of x dx is equal to f of U, right?
Yes.
Okay, let's start putting in my values here. Put in my values, this is going to be 1 over 6 minus 2 integration from 2 to 6 f of x, which is x squared, dx is equal to f of u. We're trying to find the u, right? And isn't this just the y value? This is the y value at some value of u. So what we're going to do is we're going to set this equal to my function. What is my function? X squared. And then solve for x. Solve for x, and that's going to give me my u value that I'm looking for.
Wait, so we're solving for U or we're solving for F of U?
First, f of u, right? F of u is going to give me some y value at that u, right?
Yes.
So it's basically some y value at whatever variable I have in there, right?
But then why would you replace it with the X squared?
Okay, so is this the y value? It's the y value, right?
Yeah.
Okay, let's go back and talk to this. So we're saying that the area, which is all this, okay, the area is equal to the y value. But how do I get a y value? Isn't that just f of x? In my order pair, in an order pair, I have x and f of x, right?
Yeah.
Which is the same as saying x comma y, right?
Yeah.
So I'm replacing that because I put the whole thing in there. Because normally I write my equation as f of x equals x squared.
So
And so x is some unknown value, right? And my variable that I'm using is going to be here, right? This is my y value, right? And that's my function.
wait, but why do you need to? Why can't you just solve it? And then you could go back and then once you have the F of U, you can set the F of U equal to X equals 2. Oh. Okay, yeah, now I get it.
Now, okay, all right. Is that
I
okay?
was just thinking you would have to solve for it and then set it equal to.
Yeah. So we need this. All this right here is going to give me my area.
Yeah.
So all this right here is going to give me my area.
Wait, but isn't all of that right there is going to give you the FU? And then by setting the FU equal to X squared, you're finding just the X.
Yeah.
So we're just
And
looking
the x, which is in this problem actually my u.
Yes.
Okay.
Okay.
So did I lose anyone on that? Kind of, Joseph. Let me do this one. Let me do this right here because this is the formula I'm using. So you could actually see how it goes through. And I'm going to put every item into it individually. So you could actually go back and see where this comes from. Sound good? Okay. All right. So 1 over 4 x cubed over 3 from 2 to 6. Are you okay with that so far? All right, so 1/4 times top minus bottom, so 6 to the third minus bottom, which is 216 over 3 minus 8 over 3, which is 1/4 times 208 over 3. All 208 divided by 4 is going to give me 52. Right? So that's 52 over 3 is equal to my FU. And my FU here is x squared. And I think I told you guys yesterday you had to have your calculators because everyone always forgets their calculators. Because I don't know how to do, I don't know square root of 52 over 3 in my head. I think it is 69.3. I don't know. Oh, not even close. Yeah. So I get 4. Yeah. How did I end up with it? Yeah. I don't know what I figured. Kind of retarded. That might have been the 203 one, or the 208. Yeah. Yeah. There's that, and then anyway. So 4.163. Now, this technically is my U, isn't it? That's my U. Now, I'm going to do this whole problem over again. And I'm going to do it for Joseph. What? I'm going to do it for Joseph. Because he decided to show up a lot later and then has no clue what's going on.
I'm really understanding.
You ready?
I let you know 5 minutes later. It was really like you're talking about the problem, the area in front of you.
Right?
I'll see that.
So the area somewhere is equal to the average given, this is the width, at some height. Okay, going back to the problem, I'm going to put it back in. So it was from 2 to 6 x squared dx is equal to f of u like that.
That of u is x squared.
No, this is just the y value I'm looking for.
Oh, okay.
So in an ordered pair or coordinates, this is my y and this is my x. Okay, height and width. So whatever my width is times whatever my height is. Make sense? Okay. All right, so there's going to be some value of x that's going to have the y value. When I multiply it times 4 is going to give me the same value as the actual area. So we came up that this is going to be 208 over 3 is equal to f of u times 4.
So you just divide by 4 to get your y value is 2 over 3. Why did you put x squared for f of u?
You'll see in a second. Okay. So this is the y value. So that means that the y value is going to be that. So in my graph of x squared, the y value is going to be that. Okay? So that means that there is some output value here. There's some y value that is actually this right here.
Yeah.
Okay, of the entire thing. And it's basically, I'm going from 2 to 4, so 2 to 6. So 2 is here, 6 is way up here. And so it's going to be along this, wherever that goes, that there is going to be some, this is my y value, right? And if I were to block this off from 2 to 6, this area, this estimated area, you know how we did the midpoint area, right? Which is right in the middle. We did the left hand, which is always the left. We did always the right. And so right here, I'm averaging it out from 2 to 6, here to here. So instead of being all the way to the left, all the way to the right, there's some value right here, some y value. But now given this y value, I need to find the x, right? Where does it find, where does it end up? Right? So to find this, it's a y value, but it's a y value given what function? What function am I using? Yeah, that's where I get the fu is changing to x squared. So this, right? So it is, and that's why we replace that. Because I know there is a y value somewhere here, but I just need to figure out what the x would be. So is that true? Okay, so if I put in my function,
So it's like the
if I put in my function,
what's it called again? Like the linear. I just like y equals mx plus b pretty much.
yeah.
So you just said your y equals your function.
So it's going to be x squared, right?
So you didn't really replace it. You just fix it around to be like a regular equation to actually find your value.
Yeah. Wait.
And 53 over 3.
Yeah. Where am I at? Oh, there. Okay, this is the one I want right here. So x squared. And let's find the area. So I go menu, analyze graph. I want the integral, which is the area. I started at 2, enter, upper bound to 6, enter. There we go. So that's the area. And then I have to find out where it's somewhere on there that's going to equal that. Make sense? Okay. Hopefully that helps a little bit better. But rewriting it helps you out a lot in the beginning if you go straight to this. So you don't, it's less steps than having to do all this and plug it all in from here. So it just helps you out. So those are things and formulas that should help you.
When you do that, do you have to like find the area too? So you, or
Yeah, it's basically
oh,
find
yeah,
the area of this,
area,
and then you know what the width is, right?
Yeah.
And then if I divided area by whatever the width is, it's going to give me whatever my height is. Okay. There we go. Here's more diagrams to go along with it of the whole thing. Okay. Now, here is referred to as same thing, which is just going to be the average value. The average value. This has a different name than what we just did, right? y bar, with the line on the top, right? Y bar implies that that is the average. That the average y value. Okay?
Yeah.
Make sense?
The one in between, kind of.
Yeah. So it's basically, if I had a graph
Like you were showing us different points, but
from here to here and here to here, so this is f of A, f of B, this is A, and this is B.
There's some value.
Yeah, there's some value, which is the y bar from here, just like there would be an average value here,
Which would be your mid.
which normally is referred to x bar.
Which would just be your b minus a.
Yeah. Okay. If you ever see it like this, it means the same thing though. Okay. All right. Find the average value of x cubed over the closed interval from 0 to 2. So let's start with the formula. Right, Anthony? Okay. Help me set up the formula here. Okay, what's my b?
2.
Yep. Minus a, which is 0 times integral.
Of
0 to 2, very good. Which is? Dx. Yeah. You have to close that off with dx. All right, so let's go ahead and run through this one. 1/2 integral of x4 over 4 from 0 to 2, which is x to the 4th is going to give me what, 8? 16. Yeah, 16, right?
Yeah. Over 4 should be 4.
Minus, which in the end is going to give me a answer of 2. Not too bad, right? Okay, but you have to read carefully every single time. Average value of a function is different than the
Average area.
mean value. Okay? Mean value, the word mean means average, right? Okay, so it's slightly different, so you have to actually like lock it in your brain. If it says mean, okay, you have to know, okay, it's equal to the average, where if it says average, you only want the y value. All right, rectilinear motion, net displacement, or side distance of an object whose motion begins at t equals a, ends at t equals b, is given by, from a to b, v of t dt. Total distance, which is important. Absolute value. Now, here's the difference right here. I walk from here to Douche Bros. Okay, it's about how far? It's about a mile, right? Okay, I walk back to Douche Bros. And I end up in this exact same spot. What is my net displacement there? 0. That is my net displacement. My total distance would be absolute value. I walked forward that way, and I walked backwards back. Just because I came backwards doesn't mean I'm still not walking, right? So there, I have to take care of that with the absolute value. So for these values here and here, then there's a displacement, total distance traveled that are equal. So we need to actually identify where it is, where it's going to change. Object in rectilinear motion is moving along the horizontal line with the velocity in meters per minute from 0 to 6. Find the net displacement from 0 to 6. Interpret the results in the context of the problem. So, net displacement. So if I just do the other, like I was saying, I need to try and figure out what first. Was it just the area? Was there any changes to what I was doing? It's the net displacement. Go back to the formula. Am I doing anything weird?
No.
No, net displacement, I'm not doing anything weird. I just need to find the average of that. Okay, so it's basically net displacement, I'm just going to do that right there. Okay, let's set that up then. So net displacement, I'm going to have the area from 0 to 6 of 3t squared minus 18t plus 15 dt.
You can take out the 3.
Oh, yes, I could take out 3. And that would normally be referring to as taking out my common factor, right? So, or in mathematical terms, that would be my k value. It's my constant. It's going to go out front. So, 3 integration from 0 to 6 t squared minus 6t plus 5 dt. And then I get, what am I going to get? I'm going to get 3, and then that's going to give me t3 over 3 minus 6t squared over 2 plus 5t from 0 to 6. All right, keep going. So, actually, let me, because I don't want to cram this in there. Minus 6. All right, so that's going to give me 3 times 216 over 3, 216 over 2 plus 30. Minus lower bound, which is going to be 0 minus 0 minus 0. Who's adding? Did I do something wrong? I heard someone say something, so I'm worried. Was that you? Oh, okay. Might just be the voices in my head. It's alright though. They just try to help me do math. Nothing evil or sinister. Let me see, that's 72 minus 108 plus 30. That is 102, so leaves me at a negative 6 times 3, which is negative 18. Now, interpret that for me. Go back and read the problem though. Is it dead? Oh. Borrow the one up front. Make sure you put it back. It went backwards, so it ended up after 6 minutes. My net position was backwards.
Okay.
Where? Negative 18 meters, right?
Yeah.
Right, Joseph? Is that what you're trying to tell? You ended up negative 18 meters away from where you started, right? Okay. So that's important.
That distance though, you have to do the actual value to find how much you travel.
Kind of. We have to do something before that. So total distance. Okay. Now, at some point, if I ended a negative distance, I had to at least change direction. How many times? At least once, right?
Why? Couldn't it just start that way?
I could have.
Would that still be counted as a direction?
Huh? One more time. I could have, right? But does my equation for my velocity say that?
If you had to eliminate your starting position be 0, so then if you're staring into a place and you go back or forward, you're changing direction no matter what.
Yeah, you had to change direction. At least once. So, but we're going to take that information, which was
But if you find that, change it 4 times.
3t squared, right? So 3t squared minus 6t plus 5? No.
Is that when you gotta find out?
No, it was 18, right? Sorry.
When you gotta find out where the graph changes, find any change in direction.
Yes. So here's my function.
It's been a while.
Here's my function. I need to try and figure out where this is going to change direction. So when I do that, I need to look and actually set it equal to 0. Because my velocity, when it becomes 0, that's either I am going to a stop and going forward again, or I am, changing direction.
That's the derivative though, right?
Yes, that's where we got derivatives. But isn't this already the velocity? Yes, it's already the velocity, so I set the velocity equal to 0. So you were correct by factoring it out first. T squared minus 6t plus 5. And then that's going to give me t. What's that going to be? Negative 2, negative 3. 5 and 1. Yeah. Sorry.
We're trying to find where you graph to.
Wait. So velocity is a parabola.
My velocity is a parabola. And so, but when's it equal to 0? Remember, if we're graphing it,
So you're looking for when it equals 0 because that's when it changes direction.
it would go from a negative here to a positive here, right? So that means that I could start off going left in this equation. So right here, I could start off going left, and at this time, right here, it goes to positive, and so from there it goes from negative to positive. over that interval that I'm talking about. But right here I have two of them here. So this is going to be t equals 1 and t equals 5. So I have two places that it's going to change direction. So what do I do with that information? Not negative time. This is t equals 1.
And it's equals
5, right?
oh, okay, so
Yeah. Cause okay. So, but are both of these within my bounds? From 0 to 6?
Yep.
Yes, they are. So if they're both within my bounds, I need to check. So I'm going to go ahead and throw in some values here to help me out. So from 0 to 1. So let's throw in a 0 and see what we get. So that's going to give me a -5 and a -1. So negative times negative gives me a positive. So that means that from here, I'm going to the right. Yes?
Yeah.
So I'm going to the right from 0 to 1. But at 1, let's see what's going to happen. I'm going to plug in a number right in here. Plug in 2. That's going to give me a -3 and a +1. Negative. So that means all this here is negative. So that means from 1 to 5, which direction was I going? I was going to the left. All right, so let's check this last one from 5 to 6. So plug in 6. That's going to be a +1 and a +5. Positive gives me positive here.
Right, left.
Okay, so now that we understand that, that's going to help me out. So I'm going to have a positive from 0 to 1. So from 0 to 1 of my function, I'm just going to call it v of t here.
Then how would you end up in a negative position? Alright. No, can I guess? Yeah, you don't go that far.
Okay? If I know it's going to be negative,
You don't go far enough.
if I know it's going to go negative, I want to figure out what that value is going to be though.
So you can find the total.
To get the total, right? That's why we do absolute value. How would I make this negative velocity positive? Yep. And then I'm going positive again for that last part, which is going to be from 5 to 6.
Would you have to make it negative? Because it's a negative like this.
Or you could just do, like it says, from 0 to 6. Yeah, 0 to 6. Absolute value, that one. Not 0 to 6. That one is 1 to 5. Sorry. 1 to 5. You could just absolute value that piece. Now, I wrote it just as v of t, so because I don't have to do all the work over again. I don't have to redo everything. Did I already do the integration?
No.
I already did the integration. So, doing the integration, I'm going to rewrite this. So from 0 to 1, from 0 to 1, I had, it was t cubed over. hold on. All I'm doing is finding the area of each one individually. To you know, I actually do make a video of this, so you don't have to go and just take photos.
There's the one who I said that you can go back again.
Oh,
Add the photo.
I thought you said you had to flip it.
I don't have to flip it. What did I change to this?
Oh, yeah.
I put in the absolute value bars. And if you look at my other one here, I just flipped it. So let me show you what's going to happen in flipping it here. Top minus bottom, so that's going to be 1/3 minus 6 over 2, right? Which is 3, plus 5, minus the bottom, which is 125 over 3, minus 25 times 6 is 150 over 2, which is 75, plus 25. Uh, 125 over 3 is going to be like, is it 40?
So you just broke it up.
Why'd you flip it again? I thought you said you didn't have to.
I didn't have to, but you can. I'm going to show you that it does work either way. So by flipping it, it's going to give you your answer as a positive anyway.
That's just confusing though.
Hint, hint. This is how you get your calculator to do your work for you.
But like you flipped it. I mean, you didn't flip it before, but now you're flipping it now.
Okay, what did I do different though?
You put your absolute value.
Okay.
It's confusing.
Absolute value, you're basically going to take the positive of this, right?
Yeah.
Whatever you get here, it's going to be positive.
But then why did you flip it?
I flipped it over there because I already knew that it's going to be a negative, because which direction is this going? This is all going to the left, isn't it?
Yeah.
So that's why I flipped it. So it's going to be...
So you just have to remember that it's positive.
Yeah, so if I'm plugging this in my calculator, I would flip it, just change my balance from 5 to 1 for each piece. And since I have 1 minute left, let's see if I can calculate it real quick. So, let me see, I have here an integration from 0 to 1. I'm probably not going to get to it. Tab. Alright, you can stay if you want to show you I plug it in the calculator.
Now do the statement. Let's do it again.
You gotta do the outro and everything.
So, my total distance traveled is going to be 34 units.
Okay.
Now, does that make sense?
That's why I put it there.
Blade?
Yeah, it makes sense.
So you just put in your function and just put in all that stuff there.
Yes. I put in my function for f of x, and then I can get my calculator to help me because we're approximating most of this anyway.
Do we get a calculator on the AP test? Or
Yes, but not all parts.
any parts like these we probably would.
Some parts, yeah, that you're going to have a bunch of crazy numbers. Like square root of 52 over 3. Stuff like that.
Okay.
All right.
Got it.
Okay. Make sure everyone likes, share, and subscribe. Do your homework.